Good morning, Algebra 1 CP students. This is a lesson for April 22nd for my B-Day students and April 23rd for my A-Day students. In this lesson, we're going to review the concept of square and cube numbers. It's just a type of number, like even or odd, positive or negative. We actually already talked about it once, but I'm going to remind you what a square number is and what a cube number is. And since we're kind of extending things from numbers to polynomials, we're going to review a square and a cube algebraic terms. Now, this lesson is going to be a little bit shorter than our usual lessons. I want to give the students that submitted the homework in the format that I couldn't read a chance to resubmit it, okay? So there's some of you that have to do a little bit of extra work to resubmit your homework. So I'm going to make this lesson a little shorter to give you a chance to catch up. All right. Okay, so let's go over the definition of a square number. So a square number, it's a number that can be written as a product of two identical numbers. So product means multiplied, right? So it's a number that's equal to two identical numbers multiplied. So let me give you some examples. 81, 4/9, and 1/16 are all square numbers. So like there's something called a perfect square number. A perfect square number is a whole number that has this property. But if a fraction number or a decimal number has that property, we call it just a square number without the perfect. So I'm going to justify, the homework will say justify or explain why something is a square or a cube number or term. So I'm going to justify why this 81 is a square number. And to justify it, I just have to show that it meets the criteria of the definition. So 81 is a square number because 81 can be written as, right, or is equal to 9 times 9, a product of two identical numbers, two nines. Or I can write 81 as 9 squared, or 81 is equal to 9 squared. And that's why 81 is called a square number, because it's written to, it equals to a square of another number, okay? 4/9, justify that it's a square number. 4/9 is a square number because 4/9 equals 2/3 times 2/3. So 4/9 equals 2/3 squared. Okay? And then 1/16, 1/16 is a square number because 1/16 equals, can be written as 1/4 times 1/4, or 1/16 equals 1/4 squared. And then remember remember our general rule, right? When you are raising a negative number or a fraction to a power, and you want to raise the whole thing to a power, you throw a set of parentheses around it. Okay, all right. Okay, and then a cube number. You can probably figure out what this one will be. A cube number is a number that can be written as a product of three identical numbers. So a cube number is a number that's equal to something cubed. And then product is things multiplied. So 27 and 1/1000th are cube numbers. Let's justify. 27 is a cube number because 27 equals 3 times 3 times 3, or 27 equals 3 cubed. And 1/1000th is a cube number because 1/1000th is equal to 1/10 times 1/10 times 1/10, or 1/10 cubed. Okay, so a square number or a cube number. Moving on to square terms. So a square term is a term like an algebraic term, so it has a coefficient, a number part and a variable part, right? That can be written as a product of two identical terms. So 81x squared, 4/9 y to the 4th, 1/16 x to the 10th are all square terms. So let's justify, let's convince somebody why they are square terms. And all we have to do to convince them is that show that they meet the definition, meet the criteria explained in the definition. Okay, so 81x squared is a square term because 81x squared equals 9x times 9x, right? Some of you have been getting this wrong in your homeworks, sometimes wrong and sometimes right, which is a little odd because like I'll grade a homework and half the problems are done correctly and the other one half is not. So what that tells me is that this is not this is not intuitive or second nature yet. You actually have to focus to remember this rule. But the rule is when you multiply x's, you add the powers, right? So x times x is x squared, not 2x. Because some of you have been writing x times x is 2x. X plus x is 2x, but x times x is x squared. Okay, so 81x squared equals 9x times 9x, or 81x squared equals 9x squared. Okay. 4/9 y to the 4th. So it's a square number. 4/9 I can split up into a product of two identical things. We've already done it. It's 2/3 and 2/3. Y to the 4th. Do you guys see that in order to be able to split the variable part into a product of two identical variable parts, the power has to be even because you're splitting it into two. So a power of 4 split into 2 is 2 and 2. So this is y squared times y squared. You're adding the powers, right? 2 plus 2 is 4. So 2/3 y squared times 2/3 y squared, or 4/9 y to the 4th equals the whole quantity 2/3 y squared squared. And we'll remember how to simplify that. Okay, 1/16 x to the 10th. 1/16 is a squared term. 1/16 is 1/4 times 1/4. X to the 10th is x to the 5th times x to the 5th, right? Because you split that 10 into 5 and 5. And then when you multiply x to the 5th times x to the 5th, you get x to the 10th. You add the powers. So 1/16 x to the 10th equals 1/4 x to the 5th squared. Okay, so that's a squared term. Okay, so to be a squared term, the coefficient has to be a square number, and the variable part has to have an even power. That's what it seems like, right? And we'll all right, a cubed term. A cubed term is a term that can be written as a product of three identical terms. So 27x cubed is a cubed term. Because I can write it as 3x, or 27x cubed is equal to 3x times 3x times 3x, right? Remember, x times x times x is x cubed. So 27x cubed is the product 3x cubed. And then 1/1000th x 15th. I'll pause here for a second. Can you think of a way as to write it as a product of three things multiplied? Three identical things, right? Not just any three things, three identical things. All right, did you think 1/10 x to the 5th times 1/10 x to the 5th times 1/10 x to the 5th? If you did, you're correct. So, and then remember, when you multiplying powers, you add exponents. So 5 plus 5 is 10, plus 5 is 15. Okay. All right. So all I really want to do in this lesson, so problem number 1, okay. If I tell you something is a cube term, it's kind of, when you know it's a cube term, it's easy to figure out a way to show it because you already know it is. So you're just looking for ways to confirm that. The tricky part is if you're given a term to determine whether it's a square term, a cube term, both or neither. All right, so I'm going to give you a term, and given a term, determine if it's a square term, a cube term, both or neither. All right, so 16x to the 6th. The first thing I'm going to do is look at that 16, okay, and ask, is 16 a square number? Yes, it is. 16 equals 4 times 4. Is 16 a cube number? Can I write 16 as a product of three identical numbers? No, I cannot. I cannot, right? So I'll just say 16 is a square number. All right, 16 is a square number. Good. What about x to the 6th? X to the 6th is x times x times x times x times x times x. So you actually have 6 factors. Is it a square term, variable part? Well, you can split it into two groups of identical factors, right? 3x is here, 3x is here. So I can write x to the 6th as x cubed, right? X times x times x times x cubed. And then remember, you add powers when you multiply. So x to the 6th is a square term. But also notice that because there's 6 factors and 6 is both a multiple of 2 and 3, I can split this into into 3 groups of identical products. So x times x times x, so x squared, right? X times x times x squared times x squared. So x to the 6th is both a square, it's a square term, because I can write it as a product of 2 identical variable parts, and it's a cube term because I can also write it as a product of 3 identical variable parts. So now, what about the whole thing then? Well, you have to be able to split them up together. So if 16 is a square, x to the 6 is a square and a cube, then together they're a square term. Because you can split it into two groups of identical factors. So 16x to the 6th is a square term because I can write 16x to the 6th equals 4x cubed times 4x cubed, right? So the two groups are 4 and 4x cubed and x cubed, so 4x cubed times 4x cubed. Or you can write it as 4x cubed squared. And you can check. 4 times 4 is 16, x to the third times x to the third is x to the 6th. Okay, good. So it's x to the 16x to the 6th is a square term. It's not a cube term because of that 16. All right, 100x squared. Let's think about that 100 first. Is 100 a square term? Yes, 100 can be written as 10 times 10. So 100 is a square number. Is x squared? X squared can be written as x times x. So x squared is a square term as well. There's two terms, factors of x. I'm not going to group them like that because there's just two of them, so you can split them up into groups of 1x. So 100x squared is a square term because 100x squared equals 10x times 10x, or the quantity 10x squared. Okay. Now 64x to the 12th. All right. Is 64 a square number? Yes, it is. 64 can be written as 8 times 8. Is 64 a cube number? Actually, it also is, because 64 can also be written as 4 times 4 times 4, right? So 64 is both a square number and a cube number. All right, we'll keep that in mind when we're looking at the whole thing together. Let's look at x12 to the 12th power. X to the 12th power is a product of 12 x's. So 12 is both even and it is divisible by 3. So I can split 12 factors into two groups of 6. So to get x to the 12th equals x to the 6th times x to the 6th. All right, 6 x's means x to the 6th. And then I can also split them up into three identical groups of 4s. So x times x times x times x, x times x, so x to the 12th equals x to the 4th times x to the 4th times x to the 4th. So x to the 12th is a square term and a cube term. They're both square terms and cube terms. So their product must be a square term and a cube term as well. So I'm going to say 64x to the 12th is a square term because 64x to the 12th equals 8, right, x to the 6th times 8x to the 6th, or 8x to the 6th squared. And 64x squared is a cube term as well because 64x to the 12th can be written as 4x to the 4th times 4x to the 4th times 4x to the 4th, or 4x to the 4th cubed. All right. Okay. I'm going to attach a table of perfect squares and cubes with your homework assignment. How about that? To see I have something to look at, okay? Okay.